Again, I'll have this up on Google Classroom, so if you're gone or whatever, you can always watch it. So today we're going to look at two shapes again. We had them a couple days ago, but we were just finding the areas. Now today's is on volume. When you hear the word volume, what does it mean?
The space inside.
The space inside, like how much you can fill it. Right, good job. So like for instance, if I was Tabby's Yeti water thing that she's got on her desk, how much could I fill it? Not necessarily the metal around it, correct? Okay, how much could I put inside of it? That's what it's asking for volume. So the two shapes that we're gonna look at are the prism again and the cylinder. They kind of go hand in hand. That's why they're linked together. Because to be honest, they're the same formula. It's just one's a little more specific than the other. That's the difference. Okay? So prism. Remember the other day we had prisms where a lot of times we had different shaped bottoms. Like we had either the triangle based or rectangle based or pentagon, hexagon, whatever based prism, right? So when you're a prism, to find the volume, it's big B times H. What does big B stand for? Area of the base, which means, depending on what it's sitting on, is what you'd find for that. So for instance, if it was a triangle-based prism, you would have to use the 1/2 BH and then times it by H, which gets kind of confusing because then you have two H's going on, right? This H, though, is height of the object, okay? So on these particular ones, where it's H in the formula, that's the height of the object. So for instance, if I was this wipes jug, okay, the height of the object is this height here. Okay, that's what they mean by height of the object. If I was this box of sheet protectors, which I have, which is then a prism, correct? Right? This would be a rectangular based prism. Okay, so length times width, the height of the object is this little part right here. This, what is this, about 1/2 inch, maybe? Okay, now that little part, that's the height. How tall is it? That's where the H comes in. So when you're dealing with one that is a triangle-based one, you got to make sure, especially because in our formula where it says 1/2 BH, that H for the area is on the figure of the triangle, not the height of the object. So you got to be really careful with that. They're not always going to be the same number. They could be, but typically they're not. All right? So be careful with that. The cylinder is also big B times H. But, the big but in the problem, as this is a cylinder, what kind of base does a cylinder sit on specifically? What's the formula for a circle? What's the area formula for a circle? It's on the board. Right. So instead of me putting big B times H for the cylinder, I'm going to make it a little more special. And I'm going to put pi r squared H. So instead of me putting big B, I'm going to use pi r squared because that is the area of the base. And then times by the height of the object. So I made it more cylindrical, if that makes sense. Or made it more special because it's a cylinder rather than a prism. Okay? Prisms, again, depends 100% on what kind of base it's sitting on. Cylinder, obviously, you know that it's a circle. Okay, so that's why I use pi r squared H. So for the worksheet today, you're going to find the volume. Now, on the ones that you had for the last couple days where you had surface area and lateral area and all that kind of stuff that they had, where I just wanted you to find the total area of the whole thing. All right? We're just finding one thing here. It's just the volume and that's it. All right? So on the worksheet, it's going to have something like this where it gives you that so that you know it's three-dimensional. And Calvin, give me a number.
5.
Okay. Aiden, give me another number.
7.
So it's going to say something like that, where it says 7 kilometers for the, what part is that I put down in the bottom? What would that be in the cylinder? The radius, good. And then the 5 kilometers would be the what? Height, good. So again, when you're looking at this, you look at it and go, okay, this is a cylinder. You know it's a cylinder? Can you tell? Okay, how can you tell, by the way? Because it looks like circles, even though they look like ovals, right? But you know that they're circles. So we're going to use the pi r squared h. So I noticed that somebody the other day, and I don't remember if it was this class or if it was 6th hour, but we put pi in there, and then we put the radius in there for the r, and then you put the height in there for the, and then you multiplied it all together. And the part that I saw somebody do is I saw this. So 7 squared is 49 times 5. They have the answer of 245 pi, and then for this one would be kilometers cubed. Remember, volume is always in cube. So they left it in terms of pi. Now, honestly, that's perfectly fine for me. But not everybody did that. I only saw one person. I don't remember who it was. But one person had it like that. Most of you are going to take that 245 and multiply it by 3.14 or multiply it by the pi button, and you end up with 769.3 kilometers cubed. Okay? So on the cylinder ones, that's what you have to do. Does that make sense? Is everybody good with the cylinders? Okay. Then I'm going to do one prism one. Prism, not prison. Okay? So I've got a shape that looks like this. And then this drops down like so. Now it's getting kind of sloppy. Good Lord. Okay. And then it's also got this kind of markings in here where this is like this. Like that. And then this is like this where this is all marked like that. And then it's got a thing right here in the middle that goes down to the edge, makes a 90-degree corner. And now I need some numbers from you. Kale, give me a number.
5.
5. So we'll put 5 here. Katie in the back, give me another number. 8. We'll put 8 here on the side. And Jaden, give me another number. 4. And we'll put 4 right here like that. And let's go with meters for all these, just so we have a unit. So you have one that's very similar to this one on the worksheet. Just the numbers are different because you just made up the numbers, not the worksheet. So for that particular thing, here's what it is. Is this a prism or a cylinder, first of all? Prism. What kind of prism? What? A gonal? Hexagon? Okay, let's count how many sides, shall we? 1, 2, 3, 4, 5. What's a 5-sided figure called? Pentagon. So this would be a pentagonal base. So you were close, at least you took a shot. Okay, so we got a pentagon. If you look up on the board as far as all the different ones, I have square, I have rectangle, circle, triangle, trapezoid, parallelogram. Then I put regular polygon on the bottom. A regular polygon means all sides and all angles are the same. That's why these markings right here that I'm circling, that's why those markings are there. All those are trying to tell you, hey, this means that it's regular, meaning all sides and angles are the same. So in order to find the volume, you need to find the big base times the height. Since it's a pentagonal based prism, the big B is A for apothem, P for perimeter divided by 2 times the height. So that's what I need to figure out. Okay, that's how I find the volume for this. Now, to recap, the apothem is the distance from the center of the base to one of the edges. What number is represented by from the center of a base to the edge? One of the numbers that I asked for is listed as that distance. What is the A? Anybody know what number it was? 4. This number right here, and I'll put it a little bit bolder here. This part right here that goes from the center of the base down to the corner makes a 90-degree corner. That's why it's there like that. That's the apothem. The one that goes from the center of the shape to the edge. That's the apothem. So that's the letter A. So I don't have to calculate anything for that. I just have to tell me what it is. So A is 4 in this problem, times by. Now, the perimeter of the shape. I had somebody in here yesterday ask me, how do I find P? And remember, for perimeter, which we have up there on the board, we just add all the sides together. So each side is the same distance. So you could do one of two things. You could either say, since they're all 5, you could go around the outside, around the outside, around the outside, around the outside, around the outside. You could simply add all those together. Or, since it's 5 sides and they're all 5s, take 5 times 5, which is what? 25. Divided by a deuce. And then what's the height of the object? How tall was this prism? 8. The 8 comes from the side over here, right? This shows the height. So, to calculate the final answer, I take 4 times 25, which is 100, divided by 2, which is 50, and then I take 50 times 8, which is 400 meters cubed. And again, the reason why it's cubed is because I am trying to fill it, not wrap it, if that makes sense. Okay, what do you think? I did one of each. Now, obviously, there's different prisms out there because the prisms all change. Depends on what base it's sitting on. But that's what you'd have to do for those. Okay, what do you think? Do you want me to do another one or try it? By the look of your faces, it looks like you just want to try it. Okay, so